Okay, Assalamualaikum. So now we are at the very last subtopic for variation, which is combined variation. Okay, so learning standard is to determine the relation between three or more variables for a combined variation. So combined variation involve a combination of direct variation or joint variation and inverse variation. Okay, so meaning you need to have either direct variation or joint variation to be combined with inverse variation. Okay, so let's look at mind mobilization 8. Okay, the formula for the volume of a cylinder is the product of its base area and its height. Okay, and then you need to fill in the table. If Z is fixed, okay, Z is the base area, so the height become 2, 4, 6, 8. So x over y become x over y 50, 50, 50, 50. If x is fixed, okay, x is the volume. We fix the volume, so the height will be 3, 2, 1.5, 1.2. So y times z 120, 120, 120, 120. So if x, y and z are variables, so the height for here 6, 8, 10, yz over x 80, 81, 1, 1, 1. Okay, so let's go to the discussion. What is the value of x over y? X over y is 50. State the relation between y and x if z is a constant. Z is a constant. Okay, Z is a constant, so y varies directly as x. Okay, y varies directly as x. What is the value of yz? Yz is 120. State the relation between y and z if x is a constant. Okay, x 120, yz, so y varies inversely as z. Okay, because as the value of y decreases, the value of z increases. Okay, next, the value of yz over x is 1. State the relation between y, x and z if three of them are variables. If three of them are variables, so it's a combined variations, so it will become y varies directly as x and inversely as z. So we combine them, it becomes x over z. Okay. Okay, let's move to the next slide. Okay, so here y varies directly as x. We write it this way. So inversely as z. Therefore, we combine, and then we use k, the constant. So the equation becomes y equals to kx over z. Next, example 22 and 23. Example 22. Where is it? Given that y varies directly as the square of x and inversely as square root of z. Okay, express y in terms of x and z. Okay, let's do it. Okay, so y directly as the square of x and inversely as the square root of z, so it becomes x squared, square root of z, y k x squared over the square root of z. Okay, so y equals to 8 k 4 squared, the square root of z, the square root of 36. So 8 times 6 over 16 Okay, so k becomes 3. So y equals to 3x squared divided by the square root of z. Okay, let's move to example 23. Example 23, the table below shows the values of p, q and r. P varies directly as the cube of q, cube of q, inversely as r. Calculate the values of x and y. Okay, so in the first column we have all the values of p, q and r. Okay, let's combine them first. Becomes k q cube over r. The p is 4 k q over r 0.6. Okay, 2.4 divided by 8 k, so k 0.3. Okay, so hence p is equals to 0.3 q cube over r. Doesn't look nice, so 3 q cube over 10r. Okay, so that's our equation for p in terms of q and r. So when p equals to 3.6 and q equals to 6, we need to find the value of x. X belongs to r. Okay, so let's try doing it. Okay, p 3.6, 3q 6q over 10x. Okay, so 10x 36 x cube, so x is 3 6 cube over 36 power of 1 power of 2 18, so x equals to 18 and y belongs to q, so again p equals to 3q cube divided by 10r. Okay, so p 0.081 equals to 3 qy cube, then 2.7 3y cube, 27 1 over 9 0.081. So y cube equals to 0.081 divided by 9 times 9 equals to y the cube root 0.9. Okay, so next example 24 from textbook. Okay, we just discussed the pressure P on the tire of a wheelbarrow varies directly as the mass of the wheelbarrow M and inversely as the surface area of the tire touching the ground L. Okay, so P directly as M and P inversely as L. so it become like this. Then we turn it into equation form, becomes P equals to km over L. The pressure when the mirror 19, calculate the value of P when M 120 and L 0.5. Okay, so first we need to find the value of K. Okay, so by using the 45,000 and the 90 kilogram and the 0.02 meter squared, so we got K equals to 10, hence P equals to 10 M over L. Okay, next we substitute the value of M and L to find the value of P. What can be done to reduce the pressure on the tire if the mass of the wheelbarrow is fixed? Okay, we fix the mass. The mass is fixed. What can be done to reduce the pressure? So, the pressure is P. Okay, so we need to use a broader tire because the pressure on the tire reduces when the surface area of the tire touching the ground increases and the mass is fixed. Okay, remember the mass is fixed. So here, if the value of M is fixed, P decreases when L increases. P increases when L decreases. Okay, because of the inverse variation. Okay, so if you have anything to ask, just ask me during the online class. Okay, right, thank you.